Thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Yamaha C-80 Preamplifier. Yamaha sold these between 1984 and 1985 at a list price of $750, which would be about $2,100 today. It was their next to the top of the line preamplifier and has a lot of features. We'll take a look at the front controls as well as the back input and outputs, and we'll have an inside view with the cover off, and then there will be the performance of the unit and some discussion of how it worked. Here's the close-up view of the front of the C-80, and let's start off over here. We have a headphone jack. There's our power on-off button, and an LED will come on there when the power's on. Here is the door for the controls. We'll open that in just a moment. We do have a volume control here, and this little ring on the outside, it is not the balance control. It is the loudness control. This guy right here. The balance control is kind of hidden, and it is underneath here. You can kind of maybe just see it, and it's actually on the underneath of the panel. We have our tone bypass switch there. We do have our audio muting there, phono input, DAD input, tuner input, tape 2 input, tape 1 input, and auxiliary input. Now let's pop this guy down so we can see all the controls. Let me zoom in on that a little bit more. We'll start off over on this side here. These two controls are for your low frequency equalizer. This one right here determines the center frequency of the equalizer. This guy right here determines the amount of gain or attenuation that will be applied to the frequency set by this guy. And then the outer ring right here, that affects the bandwidth of that center frequency that was selected. Likewise, for the high frequencies, this guy right here determines the center frequency, and the center pot right here determines the amount of gain or attenuation, level as they call it, and the outer ring determines the bandwidth of that change. Here we have our stereo mono switch. There is a subsonic filter right here at 15 Hertz. Here we have our record outputs for the tape monitor circuit, and this control is for the phono inputs. In order to use a moving coil cartridge, you would be connected to the phono 1 input, and you have two choices of loading. You have this guy right here, which is 1 kilo ohms, and then you have 100 ohms there. You can also use a moving magnet in phono 1, and you have several different loading choices for your cartridge. And if you want to use phono 2, you would move the switch over to here, and you have two choices of loading for phono 2. This obviously is the rear of the C-80, and we'll start off to the right where we find one unswitched AC outlet and a whopping 5 switched AC outlets. That's probably the most I have seen on a preamplifier. Also, we have a voltage selector switch, and for our preamplifier output areas, we have something I have only seen on this particular preamplifier. We do have a normal pair of preamp outputs, and then we have a pair that are inverted. And what that allows you to do is to hook up two stereo amps as mono blocks by using the normal into, say, the right channel and the inverted into the left channel on one amplifier, and connecting between the 2+ outputs of the stereo amplifier, and that would give you double the power. You also have two tape monitor loops right here. We have an auxiliary input, a tuner input, digital audio deck input, and then we have two phono inputs. Now the phono 1 can only be used for a moving coil cartridge, and we do have the ability to reduce the gain by 10 dB on the phono 1 cartridge that is used. We have a very easy to grip ground leg there as well for your phono turntable grounding. This is the view of the C-80 with the cover off, obviously, and I just kind of wanted to show what it looked like and kind of the technology they were using back in 1985. Here we have the THD SNR plot at 1 kHz with a 2-volt signal applied to the DAD input, and we have the volume control adjusted such that we have 0 dB gain or 2 volts at the output. You can see the D is pretty low, 0.000, we'll call it 1%, I guess if you round up. And the SNR is above 82 dB, so it's doing a fairly decent job. Here we have the frequency response plot with a 0 dBV signal applied to the DAD input, and the tone bypass control is off, but the tone controls are set to flat. There is a small little hump, maybe 1 to 2/10 of a dB at 25 Hertz, and at 60 Hertz there is a small little hump. That 60 Hertz is quite normal to see. We are also down about a dB at 20 kilohertz. Once again, we have the frequency response plot with the same conditions as the previous piece of data, with the exception that here we have bypassed the tone control. So it is going straight through the preamplifier without any of the tone controls affecting it. And really the main difference is that the channel balance is just a little bit better, maybe 1/10 of a dB better. And you can also tell there still is that strange little hump at 25 Hertz. The frequency response at 20 kilohertz is the same, about a dB, maybe 9/10 of a dB down. This plot shows the crosstalk or isolation between the left and right channels. In this case, a signal is applied to the left channel and the right channel is terminated into a short, and you're looking at the amount of signal from the left channel bleeding over to the right channel. There is actually a specification for that for the auxiliary input, and that would be at 40 Hertz 85 dB, at 1 kilohertz 70 dB, and at 10 kilohertz 50 dB. And it does look like we are meeting that requirement at all three frequencies. This plot shows the isolation between two different inputs. So in this case, a signal is applied to the DAD input and the source is set to auxiliary, and what you're looking at is a bleed through between the auxiliary input and the DAD input. So you would want that to be as high as possible. There is not a specification for it, but what we are seeing is that depending on the channel, the isolation at the high end of the band could be around 40 dB to 60 dB, and then at the low end of the band, it's as much as maybe 80 to 90 dB. Here we have the channel-to-channel isolation between the DAD input, which is where the signal is going in, and we have the phono 1 input selected, and also the phono 1 input is terminated. So we're measuring the leakage from the DAD input to the phono 1 input, which typically there's going to be a lot of gain in the photo stage. We also have the volume control set so that we've got 0 dB of attenuation, and there is no specification for this, but you can tell that the worst case isolation between the input is around 40 dB from maybe 40 Hertz, and then at 100 Hertz we're looking fairly good at maybe 70 dB, and then from there it just gets better to as good as about 85 dB. These plots show the effect of varying the tone controls, and there's two basic controls, which are the low center and then the high center, and that determines your your center frequency, and then you can adjust the level. And in this case, the levels were set to 2 or 4, and then the bandwidths were set to 7 or 4, and you can see the different effects of their adjustments. Also, you can compare it to the flat level, which would be the line that goes across the 0 input level axis, and it tails off about 1 dB down, because when it's flat at the high end of the band, like you saw in an earlier frequency response plot, at 20 kilohertz it is down 1 dB. So your flat level kind of is the tone controls all set flat, and then you can see the effect of each of those tone control adjustments. These plots show the effect of the loudness control, which is the ring around the volume control. And in this case, a volume of 20 means that it's set halfway between the maximum and minimum volume. For the loudness set flat, we see that we have the 0 dB gain, I will call it, at the very top. It's really not the input level that the graph is showing. It's actually the output level, where 0 would be a flat response. So if you increase the volume control, so now it's 24, and you set the loudness control up to 4, that would be the purple plot, and you can tell for all the loudness adjustments, pretty much there's a boost at around 25 hertz, and that flattens down to somewhere around no effect, around maybe 70 hertz or so. So there's a small boost in that area of the bass, but you're attenuating everything else. All the other signals are being attenuated. So I don't really know the concept behind Yamaha's loudness control, but it doesn't do anything for me as far as when I used it. I couldn't see any reason to use it, but I'm sure there might be some comments as to the brilliance of this kind of a loudness control, but it's not what I was expecting. Here we have the THD SNR plot at 1 kilohertz with a 5 millivolt signal applied to the phono 1 input, which would be set for moving magnet, and it is loaded with 47 k ohms and 330 puff. The specification is that it should have less than 0.001% THD, and that the signal to noise ratio should be 95 dB or better. Well, we are definitely not hitting the 95 or dB better SNR, and the THD is not bad. It's what, worst case 0.03% thereabouts. So it is not quite as good as the specification. However, it could still be usable. I did not hook a turntable up to try it out. And here is the frequency response of the moving magnet phono 1 input with the tone bypass on, and we're loaded with 47 k ohms and 330 picofarads, and the volume is set for 0 dB gain. You can see that we are basically plus or minus, we'll say maybe 0.8 of a dB for the left channel at the high end of the band, and the right channel is maybe plus or minus half a dB. The specification is plus or minus 0.2 dB. Here we have the THD SNR plot at 1 kilohertz with a 0.5 millivolt signal applied to the moving coil phono 1 input with the tone bypass control set to on and the 100 ohms loading selected. As you can tell, the THD is decent, 0.03% we'll call it. The SNR is pretty much the same as it was with the moving magnet setting position of this at around 42 dB. The specification calls out for an SNR of 81 dB for the moving coil position, and the THD is specified at a maximum of 0.001%. Here we have the frequency response plot for the moving coil phono 1 input with 100 ohms of loading, and we do have the tone controls bypassed. The specification is supposed to be plus or minus 0.2 dB from 20 hertz to 20 kilohertz, and we don't really look that bad, maybe plus or minus maybe half a dB worst case. However, there is a big noise spike there at 60 hertz, that big spike. It kind of comes and goes, and that is most likely caused by bad capacitors in the phono gain stage or the power supply circuit. For my listening test, I paired the C-80 with my Crown SA2 power amplifier connected to the KEF 107 reference loudspeakers. The first thing I did was check to see if there was any noise coming out of the tweeter mid-range area with everything connected, and it was absolutely dead quiet. I listened to a variety of music and everything sounded fine through the C-80. I preferred having the tone bypass control off so that I could use the equalizer controls to vary the tone a little bit more for the speakers. And they did a good job. I like having a parametric EQ rather than the standard bass and treble control. This gives you a bit more flexibility. As far as its sound, I think it sounded just fine. I listened through a couple of the inputs and I didn't notice any difference between them, even though they measured slightly different. Also, I did not listen to either phono input. I am guessing that there might be some hum with no music playing on the moving coil input if you set that up to do the moving coil. Other than that, I think it is a very nice preamp, and I think if you're able to pick one up at a decent price, it might be a great addition to your vintage stereo system. Once again, I thank you for checking out this episode and spending a little time here. And if you like the video, please hit the like button. And if you like the channel and have not subscribed, that would be great. And until next time, have a great day or night.